right, let's review some things that we talked about in our last lesson. We began chapter 10 talking about lists of numbers for which there's a rule that determines what each number is supposed to be in that number pattern. What do we call these lists of numbers? Genesis? A sequence, very good. And each of the numbers in a sequence is referred to, Kendall, as a? We don't call them numbers, we call them, Brandon? Anyone? Terms of the sequence. There we go. How do we represent the number of a particular term in the sequence? What letter represents the number of a term, class? Well, a sub n refers to any specific term. So the sub n, it's the n itself that refers to the number of a term. So n represents the number of the term. A sub n is the term itself with whatever particular number. So for instance, the 17th term in a sequence is called A17. Or we could use another letter, I suppose, as well, but A is the most commonly used. We said that the rule, again, a sequence follows a rule. What do we call the rule that determines each number in the sequence, Audrey? Cool name, starts with an A. Algorithm, I should say Audrey. Algorithm is the rule that determines each term. And we said that typically most sequences, unless otherwise specified, will just keep going forever without ever ending. And we refer to these sequences, Michael, as being infinite sequences. However, typically we'll define in a sequence, okay, I want the first 7 terms, or I want all terms under this amount, and that's a lot more practical, frankly. But a sequence that does have a limit placed upon it, we would refer to then, Maddie, as a finite sequence. We looked yesterday also at a sequence in which you can't just pick out a random term at will based on an algorithm. You have to know all the terms leading up to it. You have to know previous terms because successive terms are calculated based on previous terms. What kind of sequence was that, Abby?
Recursive.
Got a recursive sequence. And how did we notate the, quote, previous term? Anyone?
A subscript n minus 1.
Good, a sub n minus 1. And this means previous term. If you see this notation, you know you have a recursive sequence. Because the only kind of sequence that uses previous terms is the recursive sequence. We also saw one where we actually go back 2 terms previous. And that wouldn't be a sub n minus 1, class, that'd be a sub n minus 2. We won't see that often though. A sub n minus 1 is what you really need to know. But another good thing about the recursive sequence, because it hinges on previous terms, you have to know where it starts. So you have to know what A1 is, or in some cases what A2 is as well if you go back 2 terms. But you have to at least know the starting term in a recursive sequence, or else you got nothing. Right? You have to have a starting point with which to calculate. Let's go and have you just have your notes out, and I want you to solve a few of these sequences now. I want you to find just the first and 4th terms of the sequence that would be defined by this algorithm. So we're not getting the whole sequence, just terms 1 and 4. Got another algorithm for you. And here I want the first 5 terms. So we're going to limit the sequence to the first 5 terms. And then a 3rd one as well.
Are we assuming that the term is 1?
Well, n represents the number of the term. So if you're finding the first term, you're finding term number 1, n is 1. minutes a little longer to be finishing, and then we'll take a look at these together. All right, let's go and take a look at these together here. This is a basic sequence. We've got our algorithm given to us. We want just the first and fourth terms, so a sub 1 and a sub 4, to where the first time when we solve class, the n is 1. The next one we solve, the n is going to be 4, because n simply means the number of the term. So if we plug in a 1 here and a 1 here, we end up with 3 times 1 plus 2 to the first class, which is 5. 3 plus 2. If we were to plug in a 4 for each of the n values, well, now we've got 3 times 4 plus 2 to the fourth, which ends up giving us, class, 28. 12 plus 16. How many have 5 and 28 for your first answers? Okay. Any questions on the basic sequence? This next one, we're actually going to find all 5 terms of the sequence, or the first 5 terms, where the first term, of course, has an n value of 1. We plug in a 1. 1 minus 1 squared, class, gives us 0. Then we plug in a 2. 1 minus 2, you square it, you get, negative 1 squared is 1. You plug in a 3, so that's 1 minus 3 quantity squared is 4. We kind of see what's happening here. What's the next value? A sub 4. 9, and then finally 16. So pretty much just listing out our squares beginning at 0 here. How many have 0? 1, 4, 9, 16, separated by commas. You don't have to put blanks and A1s and all that underneath it, but just 0, 1, 4, 9, 16. By the way, if it were an infinite sequence, you put a dot, dot, dot at the end. Since we're limited to 5 terms, not necessary, but you'll see that dot, 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 meaning the sequence continues. Questions on the second one? This last one here has this a sub n minus 1 class. That means this is a recursive sequence because it hinges on previous terms, which means at least the first term has to be defined, and it was. We know our first term's a negative 1. So your second term then goes back to the first term, and based on the algorithm, we're going to square the previous term and add 2. Well, if we square this and add 2, what do we get, Michael?
1 plus 1, 2 equals
3. There we go. You square the negative 1 to get 1, add 2 to get 3. Well, then a sub 3 is going to look at its previous term, square it and add 2. We get what, Brandon? 11. And then a sub 4, we're going to square the previous term and add 2, and that's going to give us what, Maddie? 123. And fortunately, we stopped there. Not that your calculator couldn't have handled it, but if you're one of those people like me who doesn't like digging the calculator out, 123 squared plus 2 was not going to be pretty. How many had all 4 of those terms on the last one? All right, questions from those who did not. Do the sequences make a little bit more sense now? I know we practiced them yesterday, but seeing it now for the second time after a little bit of a break, do we feel like we understand what we covered yesterday? Any questions on those? All right, well, let's talk about a couple of specific types of sequences here. We're going to introduce one today. It's called the arithmetic sequence. The arithmetic sequence. So write that in your notes. You're familiar with the term arithmetic. That's what your math class was called when you were in elementary school. Arithmetic is a noun. You put the emphasis on the second syllable. But if you put the emphasis on the third syllable, arithmetic, it becomes an adjective, an arithmetic sequence. But I'm going to use the fact that arithmetic was what you called classes when you were younger. Because arithmetic was basic, easy math, right? It wasn't until you got older that it got harder. But, arithmetic, Chloe's in arithmetic. And, she's learning 7 plus 7 is 14. I mean, that's easy stuff, right? It's basic stuff. An arithmetic sequence relies on addition. If you want to write that key word down, it relies on addition. That's the key word to know. I'll give you the whole definition. I do want you to have it in your notes for testing and quizzing purposes. But if you'll remember, an arithmetic sequence hinges on addition. I think you'll be fine. Here's your definition for an arithmetic sequence. It's a sequence in which a constant is added. Again, there's that key word of addition. A sequence in which a constant is added to each term. Sequence in which a constant is added to each term to generate the next term, or to make the next term. Generate just sounds cool. A sequence in which a constant is added to each term to generate the next term. Sequence in which a constant is added to each term to generate the next term. And the name for that constant, write this down, is the common difference. The common difference. It's the name for the constant that is used to add to each new value. The reason, by the way, when we see difference, we don't think addition, do we? When we see difference, class, we think subtraction, don't we? Well, let's think about it. Let's take a really easy sequence here. 5, 7, 9, 11. All right, what's the number that keeps being added, class? 2. And the practical mathematic way to get that is to say 11 minus 9, or 9 minus 7, or 7 minus 5. Any term minus the previous will give you the common difference. That's why it's called common difference, but it's what is actually added. So you want to generate the next term, you add the common difference to get, class, 13, and add another common difference to get, and so on and so forth. Does that make sense? But the reason it's called common difference is because you'll get it by subtracting any number in the sequence, any term, minus the previous term. Look at page 453 in your textbooks. Look at page 453 in your textbooks. Not that you're not smart enough to be like, 7 plus what equals 9? But technically that question is a subtraction, isn't it? 7 plus x equals 9. Subtract 7 from both sides to solve the equation. So look at page 453. Now, the sequence I showed a moment ago, the numbers were getting bigger and bigger and bigger, by 2 each time, correct? But look at the sequence they give you at the top of page 453. 7, 4, 1, -2, -5. Do you notice it's descending? It's getting smaller. Well, to find the common difference, we would have to subtract any term minus previous. So, -5 minus -2, I hate negatives. -2 minus 1, nope. 1 minus 4, how about that? Or 4 minus 7. In either case, class, we get -3. Jot this in your notes. If the sequence gets smaller, then you'll have a negative common difference. If the sequence is getting smaller, if it's descending, you're going to have a negative common difference. Obviously, then if it's getting bigger, you'll have a positive common difference, but that's more normal in our minds. So you get a negative common difference anytime the numbers are getting smaller. So they showed here, by doing 3 different subtractions, that the common difference was -3. I don't know that we necessarily needed that help, but -3 is consistent throughout. All right, so then it goes from 7, 4, 1, -2, -5. We're going to add the -3 to get the next value, class. -8. After that would be -11, then -14, and so on and so forth. Questions on an arithmetic sequence. These are pretty straightforward. These were the ones on the COGAT that you figured out really quick, okay? So these are easy ones. Take a look at page 454 now. Page 454. I want 2 answers. Okay, first I want you to tell me what's the common difference. Then I want you to tell me what is the next term in the sequence. I want you to give me 2 answers each for 18, 20, and 22. For each one of these, what's the common difference? What's the next term? You could probably do these right there in your book. They're really easy. There's not a lot of space, but you don't need a lot of space. But you can do them in your notes also if you prefer. Several people already finished. Give it just a little bit longer. All right, let's take a look. Number 18. What is the common difference, first of all? Genesis?
3.
And so what's the next term? 16. Number 20. What's the common difference, Audrey?
6.
6. So the next term is 28. Number 22, what's the common difference, Kendall?
8.
And so the next term is
37.
good. Common difference 8. Next term 37. Notice all of these were getting bigger. So all of your common differences were positive. Go back and do the odds that we skipped now. 17, 19, and 21. Again, find the common difference. Find the next term. You don't find this insulting, do you, Michael?
No.
Okay. Couldn't tell by your face if that was, are you kidding me? This is so easy. Why are we even learning this?
I did it yesterday.
You did, yes, you cheater. I mean, you overachiever who took great initiative. 2 perspectives on everything, right?
Can I hide my eyes?
No, you don't have time. And once you hide your eyes, you need some prolonged period to be able to do that. You don't have time. I would say get sleep tonight, but it's a church night, so much for that. All right, number 17. What is the common difference, Brandon?
6.
6, and so the next term is?
29.
29. Number 19, what's the common difference, Abby?
-4.
Negative 4. If they're getting smaller, you have a negative common difference, and so the next term is?
-11.
Negative 11. Head off hand there. Help keep you awake. Number 21, what's the common difference, Michael?
-3.
Negative 3, and so the next term is?
9.
A positive 9. How many had all of those correct this time? Are there any questions on that? Now, obviously, finding the next term in an arithmetic sequence is pretty easy. But what about finding 20 terms out, for instance? If you needed to project numbers in statistics further out, man, that could be really annoying to have to find all those other numbers. Well, there is a formula we can use to find any number term in the arithmetic sequence. And so next thing in your notes, formula to find any term of an arithmetic sequence. Formula to find any term of an arithmetic sequence. Again, would it be wrong to just, solve 20 numbers in a row? No, not really. It wouldn't be that hard, perhaps, but I mean, the further out you get, the more work it is. It'd be nice if there's a formula, and there is. And it's a fairly logical formula, I would say, as well. As with all algorithms, it'll start a sub n equals. And let's think about it. If the common difference, class, is you're just adding this certain number over and over and over and over again, right? Let's think. If we go to, say, the 4th term, how many times have we added the common difference? 3. The first time we started with a number, right? But then we just added the common difference 1, 2, 3 more times to get to the 4th term. So what we're going to do is we're going to say, okay, let's take our starting number, a sub 1, and then let's add to that the product, if you will, of the common difference and 1 less than the term we're finding. So we're finding term 4, that's 3 times we're going to add the common difference. So we'll take n minus 1, 1 less than the number we're finding, times d, the common difference. So it's a very logical formula. Starting number plus common difference used 1 less time than the term we're finding. So very quickly, the n, again, here simply refers to the number of the desired term. So we're finding the 20th term, for instance. Okay, 20 is the n. Again, n minus 1 refers to the number of the previous term, not the actual previous term, but the number of it. A sub 1 obviously refers to the first term. We should already remember that, but you can jot it down if you want to. And d here represents the common difference. The common difference. So again, fairly logical. I don't think any of that's like, man, I don't get it, or that's going to be hard to remember. I think it's pretty straightforward. Look back, if you would, on page 453 at the example at the bottom of the page. Go and read the example problem that's in bold for us there, Abby.
Find the 5th term of an arithmetic sequence in which the first term is 3 and the common difference is 6.
All right, so the first term is 3. Now it says find the 5th term. One way we could do this, right, class, is say 3. Well, the common difference is 6. What's the next number, class? 9, then 15, 21, 27. Boom, there's my fifth term. Admittedly, it's only 5 terms. That's not real hard. The formula says this. Let's start with our first term, which is 3. Now we're finding the fifth term, so 1 less than that be 4 times. We have to add the common difference, which is 6. 24 plus 3 is 27. So again, for a fifth term, was it that much work saved? Probably not. But again, as you can imagine, you go out to the 20th term. That's going to make a world of difference. Page 454, turn the page. Page 454. And let's look at this example as well. Read the problem for us here, Audrey.
Find the formula for the nth term of the arithmetic sequence -3, 2, 7, 12, 17. Use this formula to determine the 15th term of the sequence.
Well, we already know our formula, and it's going to be this one. Say it with me, class. A sub n equals a sub 1 plus n minus 1 times d. Again, a sub n equals a sub 1 plus n minus 1 times d. And it wants us to find the 15th term. So we're finding a sub
14.
Finding the 15th term, so we're finding a sub 15, the number of the desired term, is going to be a sub 1. Well, looking at the beginning of the sequence, we know what a sub 1 is, class. -3 plus, and we're going to take 1 less than the number of the term we're finding, 14. So 14 different times we're going to add the common difference, but they didn't tell us what it is. We got to figure it out. To go from a -3 to a 2, yeah, or 2 to 7, 7 to 12, those are easy. What's the common difference, class? 5. So if you got the common difference, and then the calculator can do the work from there, unless we're really good in our heads. What do we get for the 15th term? 67. Now again, here's where I say that's got to be faster than going through the trouble of counting by 5s until you figured out. Plus, then you got to be like, did I hit the 15th term? Count them all, make sure it's really the 15th term, and then, if you're like Audrey, you're like, did I count correctly? So you count a second time, you count backwards just to, I've done that, so I'm not picking, I know, but it's easier, right? The formula. Look in your textbooks now, if you would, over at page 455, right across the page from the example we just looked at. Look at number 24. We're finding which term given what information. Go ahead and read that for us, Michael.
8th term, the first term is 5 and the common difference is 2.
All right, number 24.
24. 6th term, the first term is 8 and the common difference is 3.
All right, so we're going to go to a formula, but since we're finding the 4th term, class, we're finding a sub 4 is going to be equal to, and it says the first term was 2, plus, since it's the 4th term, we're going to go 1 less, 3 times the common difference, which they came right out and told us was 7. That's all there is to it. We'd follow order of operations, class. What's the 4th term? 23. Thank you, Brandon. Do the rest of you follow along with what Brandon and I were doing? All right, all of you now on 26. We're going to be finding, class, on number 26, a sub 10. Thank you, Audrey, because it's the 10th term. I need to start by writing a 3, because that's the first term, plus, since we're finding term 10, class, what number goes here? 9, 1 less, times the common difference, which they told us is 11. And we use our calculator if necessary. What is the 10th term, class? 102. 99 plus 3. Questions on this? All right, do 28 and 30. Do 28 and 30. Using the formula to find any number term within the sequence. Did you do this last night too?
No.
Okay, you're just that fast, okay. $28 and 30. Finishing just the last couple of evens right there in that little section. 28, I'm thankful for a calculator. Sometimes I have to weigh, is it lazier to not reach for the calculator and just do it in my head, or is it lazier to get the calculator? 28, pretty easy decision. And what do we get for number 28, Michael?
868.
868. How many had that? 868. So we're going to start with a 4. We're going to add 1 less than the number. We're finding the 33rd term, so 32 times we're going to end up having to add a 27. So multiply to get big number, 864, and then add 4 more to get the 868. Question? You see it now? Okay. And okay, and then number 30, that would have cleared it up. All right, and then number 30, finding the 10th term, starting with the first term of 1, and then a common difference of 36. What do we wind up with for our answer here, Maddie? 325. How many of that for number 30? All right. Questions on either one of those? Yes, ma'am.
So 28 is 598.
28 is 868. So on the calculator, you're going to multiply these two numbers together. Yeah. So 28, 33rd term is what we're finding. So we're going to multiply 32 times the common difference, then add the first term 4. Go back and do the odds, 23 to 29. 23 to 29 at the odd now. Like brother, like sister. Oh, I see eyes. You're like, I'll work ahead so I can hide my eyes. Well, that's heads up, 7 up when you put your thumb up. Not gonna hide your eyes too?
I would fall asleep.
Oh, okay. Is she gonna fall asleep?
Most likely. You should probably have Genesis poke her with a pencil every once in a while, just to make sure she stays awake.
Don't touch me.
It looked like it was perfectly level. It worked.
I can't look back. I was like, what is that on my head?
It was amazing.
I was looking at it's like a little platform right there when she rests her head like that. She had a coffee mug, but all I had was a water bottle. Take my bottle back. Just not touch the bottom now.
I thought you were gonna pour it on her head.
No,
Me too.
no, I'm not that mean.
I am.
Besides, I get her math book wet. Can't do that.
That makes her at the bottom. I don't think this paper really messes up anyway.
I don't know. I wouldn't trust it. And her calculator could get wet. That's a TI-30XA. You don't want to get
Well,
$10. Well, okay, plus tax. If you're in Alabama, yeah, it's closer to 12. Probably inflation. It probably has gone up. I haven't checked prices since Biden took office.
We got ours at Staples, so.
Okay, see, I'm a Walmart guy, strictly Walmart.
That was probably smarter.
Cheaper.
Definitely.
It's like going to a zoo. You see all kinds of strange life forms while you're there, too. Free admission. All right, number 23. Abby, what'd you get for your answer?
17.
Oh, 19.
Mm-hmm.
So 7 times 2 and then plus the 5. Number 25 for redemption. Abby.
Oh, I did 6 times 2. 23.
23 is correct. Number 27, Genesis. 255. And number 29, Brandon.
37.
37 is correct. Anyone go 4 for 4? Got them all? Anyone just missed one? All right, we already know what happened on yours. Which one?
27.
27. What was your answer?
I did 27.
You had 27 for your
I
answer.
got a side. I looked at the wrong thing and got numbers somewhere.
Gotcha. So instead of 9 plus 6 times 41.
I did 9 plus was 6 times 3.
Hmm.
I looked at 25.
Oh, I see. Yep, because the common difference was 3 right above it. That makes sense. All right, questions? All right, you can set your book aside for just a minute or just ignore its existence for a moment. I want you to find the 8th term of the sequence that begins 7, 2, negative 3. And for the arithmetic sequence beginning 1, 5, 9, I want you to find the 16th term. Foiled, he found a way to keep me from working ahead, to make up his own problems. He still finishes first. We need that big bubble wrap. If it's not in the box. We don't actually hate you, Abby, I promise. Okay, I don't actually hate her. So Audrey, as we look at the first problem here, we start with our first term, of course, which is 7. Then we're going to add the product of 7, because we're finding the 8th term, so we're going to go 1 less. 7 times, we're going to have to add the common difference, which is negative 5. Should have had a negative common difference here. So if your answer was 42, you forgot the negative. Should have had what for your answer? Uh-oh. Did you have 42? Hey, at least you caught the common difference yourself when I called on you. Should have had what for our answer here? I thought you just worked it. Help, class? Negative 28. 7 negative 35 is negative 28. How many had that answer? How many were like Audrey and had 42? It's a mistake I could see people making. Okay, Gavin, thank you. All right. He's like, no, I had the negative 20. Not helping. All right, looking at the next one. We want the 16th term, but of course, class, we start with the 1, which is our first term. And since it's the 16th term we're finding, we're going to multiply 15 times the common difference, which is, Kendall? 4. And so our 16th term ends up being 61. How many had 61 for the second problem? All right, questions on this one. Turn over to page 461 now. Page 461. At the bottom of the page, I want you to do numbers 9 through 12. Page 461. At the bottom of the page, do numbers 9 through 12. It's in the review section. Got a couple recursive sequences to practice with, and then a couple of arithmetic sequences as well.
uncomfortable.
He should.
Poor Brandon. It's a rough life.
We were actually talking about what Hard Knock Life means yesterday night. I started singing that song, he's like, what does that even mean?
Where's that from? I'm pretty sure I've never seen it, but I've heard the song pretty much my whole life, or at least those 2 lines, right?
Just a little longer to be finishing up, and then we'll take away these together. Let's go and take a look and start with 2 recursive sequences. Now, they said in the directions they were recursive, Maddie, but they didn't have to tell us that. We would have known they were recursive sequences as soon as we saw, see the a sub n minus 1. And what does this actually mean, class? Previous term. So you have to define the starting term. So they start the sequence at 2. And then we're going to do 7 times previous, add 2, which gives us what for our next number here? Michael?
16.
16. Then, okay, let me get the answer key. I'm not so good with my 7 times 16s and adding 2s. What's the next term going to be, Kendall? 114. Really good to use a calculator, because if you screw one up, you're doomed to screwing the rest of them up. What's the next one after that, Genesis? 800. And the next one I could actually do in my head. And what did we end up with, Abby?
56,002.
5,602?
5,602.
There you go, 5,602. And the fun part about a sequence, right, is when you start introducing commas into the numbers, and then you switch to semicolons, just like in English class. If there's already commas around, you upgrade to semicolon. See, it's just like English. How many have these 5 numbers for number 19, these 5 terms? All right, then looking at the next one, again, a recursive sequence. We're going to start with a 3, and this one's ugly because we end up with fractions. We're going to have to take the previous term 3, divide it by 2, and then add 3 to that. What does that end up giving us, Audrey? 4.5 or 9 halves. I usually do improper fractions, but 4.5 is fine. Then we've got to divide that by 2 and add 3 to that to get what, Brandon?
Yeah, I get it wrong.
Okay, go and plug it into the calculator if you need to.
Five and a fourth.
5 and a fourth, or you might have 21 fourths. Of course, I think the calculators do the mixed numbers. If we're using calculator, 5 and a fourth would make more sense, wouldn't it? And then finally, we're going to take half of that and add 3 to that to finish with what value, Maddie? 45 over 8. Did you do that just for me, or did you actually have 45 eighths? Great job. Or you might have had 5 and 5/8, I suppose. Would have been the same thing. How many had those numbers here? Let your calculator handle all those nasty fractions. Questions on this? All right, let's look at numbers 11 and 12. Number 11, what is that formula that I need to use here, Michael, to find any number or term?
A sub n equals a sub 1 plus n minus 1 times c.
There we go. And so since we're finding the 15th term, of course that's a sub 15, we'll start with a sub 1, which is?
13. No, wait,
5.
5.
And then we're going to add
14 times 13.
14, 1 less than the 15th term times the common difference, 13. End up with what for term number 15?
187.
187 is correct. How many had 187 for that 15th term? All right, then on the next one, we were finding the 10th term, so a sub 10. And Audrey will start with the first term, and we'll add to it
9
times 6 was the common difference, and we end up getting 57. How many had that for number 12? All right, questions on number 11 or 12? Any questions at all on any of these? How many were at 4 for 4? You got them all, even the one with the fractions in it. Good? Questions? All right, no homework this evening, but we will be taking a quiz in our next lesson over section 10.1. So what we covered yesterday, what we covered today. Now we will review before the quiz, but I would encourage you, skim over your notes tonight or tomorrow after achievement test. Have your notes with you so when you finish achievement test early, you have a moment to skim it over, unless you say, I don't finish achievement test early, in which case don't bank on that then. Study tonight. But no written homework from me this evening. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.